Welcome to this explainer. Look, today we're completely bypassing the usual software hype cycle. We're going to forget about the latest chatbots, forget the generative art for a second. Instead, we're diving deep into the systems-level physical infrastructure that is, quite literally, rewiring human civilization right beneath our feet. We're basing this on Stephen Witt's really profound analysis in The Thinking Machine, and we're going to uncover how a company called Nvidia didn't just build faster microchips, they fundamentally rebuilt the entire engine of human progress. So let's dive into this. I want you to fundamentally rethink what the word intelligence actually means today. Because for all of human history, intelligence was trapped inside biology, right? It was this thing forged over millions of years of evolution, housed inside a skull, and strictly limited by a human lifespan. But what happens when that's no longer true? What happens when cognition can literally be manufactured in a foundry, shipped in a massive crate, and scaled up just by plugging it into a power grid? We aren't just teaching machines to think anymore. We are mass-producing the act of thinking itself. I really want to slow down here for a second and let the sheer philosophical weight of this thesis sink in. Humanity is no longer merely building tools. Humanity is building industrial-scale cognition. Think about the wheel, or the printing press, the steam engine. Those were tools. They amplified our physical muscles or our ability to store information. But industrial-scale cognition, that is a profound civilization-altering shift. The absolute central resource of our civilization is transitioning away from physical materials to programmable intelligence. And to understand exactly how we got here, we actually have to look at a microscopic accident. Act 1, the microscopic accident. You see, this whole revolution, it wasn't planned in some grand futuristic laboratory. It was actually born out of a really desperate need to render pixels on a screen. So in traditional computing, the CPU is built on sequential logic. Imagine you've got a single, incredibly brilliant mathematician who can solve literally any complex problem you give them, but they can only solve one problem at a time. That's your CPU. But a GPU, a graphics processing unit, works totally differently. Instead of one brilliant mathematician, imagine an army of 10,000 average workers, all performing very simple calculations at the exact same millisecond. That is massively parallel computing. For decades, the entire tech industry was absolutely obsessed with making that single mathematician faster. But as we now know, the future actually belonged to the army. And the irony of how this played out is just staggering. Why would anyone need thousands of simultaneous calculations back in the 1990s? Well, video games? To render a cool 3D explosion, a computer has to calculate the lighting and the trajectory of thousands of pixels all at once. So gamers, completely by accident, bankrolled a massive, multi-billion-dollar economic demand for parallel processing. It wasn't until decades later that researchers suddenly realized neural networks, which are the foundation of modern AI, are fundamentally just giant matrix multiplication engines. They require the exact same kind of parallel math as rendering a video game explosion. It was the hardware architecture that caused the revolution, turning AI from a quiet theoretical science into a brutal industrial compute competition. Act 2. Building the invisible moat. Now, physical chips are just silicon and metal, right? Eventually, they can be reverse engineered, they can be copied. To understand Nvidia's true, unshakable dominance, we have to look at the invisible layer that secured their control over the future. Enter CUDA. Introduced back in 2006, CUDA is technically a software platform that lets researchers program GPUs for general-purpose math, not just graphics. But defining it simply as a software framework is doing it a massive disservice. CUDA is dramatically more than that. It is literally the foundational operating system of the modern AI era. While all their competitors were hyper-focused on just trying to build a slightly faster chip, Nvidia was quietly building a trap, an incredibly useful, brilliant trap. Because they made CUDA totally free and integrated it super deeply into universities and startups, an entire generation of AI researchers learned to write code specifically for Nvidia's ecosystem. Ecosystems are harder to replace. That's the secret. If you wanted to switch to a competitor's chip later on, you'd have to rewrite all your software from scratch. Nvidia didn't just build the engine, they paved the only roads the engine could actually drive on. Act 3. The hybrid systems architect. So, who actually had the foresight to build this invisible moat long before anyone even knew what artificial intelligence would become? Well, Jensen Huang fits a very specific, incredibly rare profile. He's a hybrid systems architect and a wartime operator. Nvidia didn't just smoothly glide to a $1 trillion valuation. No, They survived multiple near-death experiences. Wall Street completely dismissed them for years, writing them off as just this niche graphics card business for gamers. But Huang was driven by technological inevitability. He built his conviction from first principles, enduring intense humiliation and market rejection, basically just waiting for reality to catch up to his vision. He knew deep down that parallel computing would eventually swallow the world. And that brings us to the sheer magic of timing. Just watch how these historical layers compound. In the 90s, gamers are funding the hardware. Boom. Then in 2006, the CUDA software coordination layer is laid down. By 2012, academic deep learning researchers finally discover the power of these GPUs. And then, in the 2020s, internet-scale data and massive, unprecedented capital violently collide with this mature foundation. Exponential growth always appears sudden from the outside, but these foundations were being meticulously built layer by layer for decades. Act 4. The physics of intelligence. To truly grasp where we're at today, we actually need to rip ourselves out of the digital realm of code and drop right into the heavy metal and concrete reality, because most people still think AI progress is just about writing smarter software. It's really not. Advanced AI is now heavily constrained by infrastructure physics. Training frontier models is a brutal manufacturing problem. You need enormous semiconductor fabrication. You need optical interconnects moving petabytes of data across sprawling data centers. We are talking about massive gigawatt power delivery systems, literally the energy required to power small cities, and you need advanced liquid cooling just to stop the chips from physically melting themselves into slag. Nvidia optimized entire computational systems, not just isolated chips. They mastered the actual physics of intelligence. I want you to really engage with this realization right now. If the barrier to advanced AI is no longer just who has the smartest researchers, but rather who can actually secure enough power, cooling, and silicon fabrication, well, the whole game has fundamentally changed. The real winners are the entities that can coordinate these massive physical supply chains. The true barrier to frontier AI today is sheer overwhelming infrastructure scale. Act 5. Geopolitics of artificial cognition. Look, when compute becomes this physically demanding and this vital to civilization, it completely stops being a tech industry story. It becomes a story about the fate of nations. In the 19th century, global power was determined by who controlled steam and coal. In the 20th century, the true superpowers were the ones who controlled electricity grids and oil shipping routes. Today, right now in the 21st century, advanced compute and semiconductors are the new foundational infrastructure. AI chips are no longer just consumer electronics, they are the ultimate strategic national assets. Compute is the new oil, period. And because of that, we have incredibly fragile geopolitical choke points. Hyperscale compute access now directly dictates a nation's military and economic competitiveness. Yet, the physical manufacturing of these incredibly advanced chips is overwhelmingly concentrated, heavily reliant on foundries in Taiwan, specifically TSMC. The physical locations of new AI data centers are literally being dictated by where we can find enough untapped electricity on the grid. We're witnessing a totally new phase of civilization, where a tiny fraction of megacorporations and hyper-localized manufacturing hubs sit at the absolute choke point of human progress. Nvidia started out by rendering pixels for video games. Today, they, along with a tiny handful of other entities, control the engines of industrial-scale cognition. When the intelligence that's going to run our economies, our medical science, and our global defense systems is constrained by physical hardware controlled by a few massive firms, who truly shapes the future? Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.